Okay, so we continue with our topic number 4, okay, on binomial distribution. Okay, so last Monday we have discussed on discrete probability distribution, okay, whereby I introduced to you what is the concept of discrete, what are the characteristics of a discrete distribution, probability distributions, and examples of discrete versus continuous. And also we look at how to calculate the mean and also the variance of from a probability distribution. Okay. So and again, as I mentioned before, the focus for topic number 4 is on the two discrete distributions, which is binomial, okay, and also Poisson distribution. So today we will cover on binomial, and by next Monday we're going to start on Poisson distribution. So most of the questions in your test 2, okay, will cover on these two, binomial and Poisson. Okay, so okay, so we're going to start on binomial distribution. Okay, so being part of discrete probability distribution, okay, as what we discussed last Monday, discrete distribution requires the main characteristic is that the outcome takes exact value, okay? 1, 2, 3, the number of houses, the number of cars on the road. So those type of events require a discrete distribution, and one that we can use is binomial. Okay, and the main characteristics are these 4. Okay, being the first one is there are only 2 possible outcomes, okay, of a trial. Okay, it's just like if you ask a question, are you a male or female? Okay, there's only 2 possible outcomes, and each outcome are mutually exclusive. Okay, we already discussed last Monday what is mutually exclusive, whereby the outcome of the first event will not influence the outcome of the second event. Okay, it's like just like our experiment that we discussed last Monday on tossing a coin 3 times. So if you toss a coin the first time you get hit, okay, does not mean that because the first time you get hit, second time also you will get hit. Okay, so what happened in the first toss will not influence the outcome of the second time you toss the coin. Okay, just like if you roll a dice, okay, baling dadu, okay, you roll a dice and let's say the first time you get number 6, okay, there is no guarantee that the second time also you will get number 6. So that is mutually exclusive. And the random variable is the result of counts, which means the experiment is based on how many times you perform the event, okay, whether 6 times, 10 times you perform the experiment. Okay, and each trial is independent, okay, which is similar to mutually exclusive as well. So let's say you have you attempt tossing the coin, okay, 3 times. Okay, so every time you toss the coin, the first trial has no connection with what happened on the second trial, meaning the first time you toss the coin, okay, has no influence what happened when you toss the coin the second time, the third times, okay, and so forth. Okay, but the main one is this one. I mean, there are only 2 possible outcomes. Okay, so this is something that you need to bear in mind. Okay, so when we mention that there are only 2 possible outcomes, we call it the outcomes is categorized into 2, success or failure. Okay, so do not refer the word success as the word success that we usually use in our day-to-day life. Okay, but in terms of experiment, when it comes to probability, binomial probability distribution, the word success refers to what is the event that you are looking for. Okay, for example, in the previous example, you want to see how many times you get hit. Okay, when you toss the coin 3 times, okay, how many times does when the coin land on the floor, okay, the hit will appear on top of the shilling. So the number of hits appears. So the event of hit appears is the probability of success. If the coin land on the other side, on the tail side, so that will be the probability of failure. Okay, so that is what it means by success or failure. It refers to what is your targeted or what is your objective of the experiment. If your experiment want to see how many times you get hit, so the number of hits will become the success, the probability of success. Okay, and the other event will be the failure. Okay, and then the number of trials will be fixed. So let's say you said that you want to toss the coin 10 times. So you can only toss the coin 10 times, okay? Not less and not more than 10 times. So the event must be fixed. You cannot simply decide, okay, later how many trials. Let's say you want to get the number of hits 3 in a row, okay? You want to get hit. So no matter so you will only stop the process or the experiment until you get 3 times hit. Okay, so that's not how it works. Under binomial distribution, the experiment, you must set how many times you want to perform the experiment. 10 times, 20 times. Okay, and the probability of success or failure stays the same. So if the probability of getting a hit, let's say 0.2, okay, then it will stay the same throughout the event. Okay, it will not change. So the probability of success and failure stays the same, and the trials are independent. Okay, as what we discussed. So if you perform the experiment 10 times, each time, every time you perform the experiment or the trial, okay, the first trial has no influence on the second trial, the third trials, okay, and so forth. Okay, so and this is the formula of a binomial distribution. If you look at your scientific calculator, you're going to see the C button, okay, or the NCX button. C denotes combination. Okay, how many combination is possible? Okay, so based on this formula, C denotes combination, N is the number of trials. Just now we mentioned that the number of trials will be fixed. X is the random variable defined as the number of success. So basically PX, okay, let's say you want to see how many times you get hit 2 times. 2 times when you toss the coin, hit will appear twice, okay? So, or for example, how many times when if you want to do an experiment, okay, within, let's say, how many students will get B plus, okay, at the end of the semester. So so let's say the probability of student will get B plus. So PX is the event that you said, okay? The probability of 10 students will get B plus, or the probability of 20 students will get A. Okay? So the X is the event or is the random variable that you are looking for in terms of you want to calculate the probability of that particular random variable. And pi is the probability of success. So just now we defined that the probability of success and failure remain fixed. Okay, so and you can see here 1 minus pi, pi is the probability of success. 1 minus pi means 1 minus the probability of success. So from here you can see that pi and 1 minus pi for the probability of success. Okay, let me refer to the previous slide. Okay, the probability of success and failure. So success from the formula is denoted as pi. Okay, and failure is denoted as 1 minus pi, means that when you combine both success plus failure, the value must always be equals to 1. So let's say the probability of success is 0.2. Okay, that means the probability of failure will be 0.8. Okay, so the total between these two will always be equals to 1. So that's what it means when you look at this formula. Pi is the probability of success by the power of x. Okay, 1 minus pi means once you put pi, let's say 0.2, then this value will be 0.8. Okay, so that is the standard binomial probability formula. Okay, so if you want to calculate px equals to 2, so basically every information will be provided. So you will know what is the number of trials, what is the x that you are looking for, and what is the probability of success. So basically just plug into this formula and use your calculator, okay, to perform the calculation. Okay, so this is the first example from the slide. Okay, there are 5 flights from this from point A to point B here. Okay, suppose that the probability that any flight arrives late is 0.2. Okay, so just now we mentioned that there is whenever you want to do a binomial probability experiment, you categorize into the event is categorized into 2, success or failure. Okay, so the word success, as I mentioned, does not mean that it must be a positive thing or something good. Okay, it refers to what is the event that you are looking for in terms of what is your objective for that particular experiment. So that will be the event of success. So here in this example, okay, any flight arriving late is the probability of success, because this is what you are referring to as the main event. So if you look at the question here, what is the probability that none of the flight arriving late? Okay, so flight arriving late is something bad, okay, or something negative, but that does not mean that you cannot. I mean, that's why when we refer to the event of success versus failure, okay, the word success does not mean that it refers to something good. Okay, but when it comes to binomial distribution, success means the event that you are interested to investigate. So here the event that we want to investigate is the flight arriving late. So 0.2 will be our pi. So meaning our 1 minus pi, or the probability of failure, the event of failure will be 0.8. You can see here, okay, 0.2 here is our pi, or the probability of success. Okay, here just now, pi is the probability of success. So our success event will be the flight arriving late, which is 0.2. So the number of trial fixed at 5. So there are 5 flights. So n will be 5. Pi will be 0.2. And what is our x? So our x is what is the probability that you want to calculate based on what event? So you want to calculate the probability of 0, meaning px equal to 0, or in other words, there is 0 flight that arrives late, or in other words, all the flights arrive on time. Okay, so we are referring to the flight arriving late as our probability of success. So we want to calculate what is the probability that 0 flights arriving late. So px equal to 0. So just plug into this simple formula here. NCX, okay, 5 choose 0. Okay, again, this command or this button, I mean, this symbol here is when you use a scientific calculator, you will be able to see the C button. Okay, so 5 choose 0, 0.2 by the power of x, x will be our 0 here. Okay, and then 1 minus 5, which means 0.8 by the power of n minus x. So our n will be 5, number of trials just now, okay, minus 0. So basically this part is basically 5 minus 0 here. So you solve for that and you get the probability of 0 flight arriving late will be 0.3277. Okay, and I also provided to you the online calculator for binomial under this the SOC statistics. Okay, and one of them will be for the binomial test calculator, okay, that you can find on the website here. So in that calculator, you have N, K, and P. So N is similar to the number of trials. Okay, P will refer to the pi, okay, or the probability of success. You can refer to this one here. And K here is similar to our X, okay, here. So NCX, okay, N is the same number of trials. K here will be the X, meaning the event that you want to calculate. In this example here, K will be 0, meaning K is X lah. Okay, you want to calculate 0 flights arriving late, so K will be 0, and P is the probability of success, pi. So if you plug in the same value just now, 5, and then K will be 0, Px equal to 0, and the flight arriving late will be 0.2. Okay, so you just calculate, and then you will get the value will be the probability of exactly 0 will be 0.32768, okay, which is same here, 0.2. Of course, when you calculate manually, it will not be the same as you key in from the computer, but this is almost 99% the same, okay, 0.3277. Okay, so that's how you can solve. I will explain what it means by this second part here, okay, depending on the type of questions that you get. But the first one is when you want to calculate px equal to something, okay. So the part from the first part here, okay, refers to px equals to, okay, px equal to something, okay. So this is exactly equals to what? So px equals to 0 or px equals to 1. So if you want to calculate px equals to 1, just put 1 here and you get the answer on this first line here, okay. So that will be using the calculator from the online tool, okay. So you can arrive at the answer to calculate px equal to 0, okay, from this first line. So simple job, okay. So, and you can also do this manually in your calculator as well. You should be able to get the same answer, okay. So the main thing is that you need to know which one is the number of trials or the n, okay. So here n is 5, and what is the probability of success, okay. So the word probability usually refers to a value between 0 to 1, okay, whether in term of percentages or proportion. Here is in term of proportion, which is 0.2. If let's say if we change the word, I mean this line into, suppose that the probability any flight arriving late is 20%. Okay, so it refers to the same thing as well. Okay, meaning 0.2. So it can be in term of proportion 0.2, or it can also be in term of percentages. Both are referring to the probability, okay, between 0 to 1. Okay, and then what is the event? The variable that, I mean the event, I mean the probability of event that you want to calculate, which is the x value. Okay, so this is how you perform. And just like any other distributions, whenever you deal with a probability distribution, okay, you can also calculate the mean and also the variance. Okay, because when we learn what is the mean, okay, the measure of location. Okay, we want to know what is the average value, what is the value in the middle of the distribution. Okay, and also we want to know what is the measure of the spread of the data, the dispersion, which is the variance. So for a binomial distribution, the mean or the mu is n times pi. N means the number of trial multiplied with pi, okay, the probability of success. And variance is just adding another component here, n pi 1 minus pi, meaning number of trials multiplied by event of success, probability of success, multiply the probability of failure. Then you will get the variance directly, okay, not standard deviation. If you want a standard deviation, the answer from this, you need to take the square root of this, okay, because standard deviation is always smaller than variance. Okay, variance is the square of standard deviation. Okay, so for example here, from the same example, the number of trials just now is 5, pi is 0.2, so n times pi, you get the mean to be 1.0, meaning on average, there is one flight arriving late, okay? Whereas the variance will be 0.8, n pi 1 minus pi, 5 times 0.2 times 0.8, okay? Because we know that pi and 1 minus pi always equals to 1. Okay, so if pi is 0.2, so 1 minus pi is 0.8, or the probability of failure will be 0.8, the probability of success is 0.2. Okay, you solve for that, you get the variance to be 0.8. Okay, remember this is variance. If you want standard deviation, you need to take the square root punca kuasa 2 of 0.8. Then you should be able to get the standard deviation. Okay, so that is, okay, if you refer to past year's question from the library, okay, if you were to take this exam, this test face to face, okay, meaning that beside the calculator, you can also refer to the table. But I'm not sure why the latest version of the ebook, okay, they have removed the binomial, wait, yeah, you have this one, right? You can see here, okay, in the appendix of tables, okay, you have the binomial probability distribution table. Okay, so here you are given the value of n equals to 1, n equals to 2, n equals to 3, 5, 6, okay, until to the biggest value of n will be n equals to 15. So as if the questions that you do, the value of the n, the number of trials is between 1 to 15, then you can refer to the table to get the answer. Okay, if you do not want to use the calculator, your manual calculator or your online calculator. So this is one of the ways to obtain the answer. Okay, but the limitation from this table is that you can only get the answer if the number of trials is between 1 to 15. So if you recall just now from the example of this one, the flight arriving late, okay, if you look at this example again, n equals to 5 and the pi is 0.2. Okay, so here you can refer to when the n is equals to 5, okay, and pi is 0.2 here. So you can refer to this value, okay, and you can see that when px equal to 0, so you refer to px equal to 0, okay, given that n equal to 5 and pi is 0.2, and you get the answer here, 0.328, okay, which is similar to this one, 0.2377, okay, because the answer from the book, from the table, they only run up to 3 decimal places. Okay, but you can refer to the book as well, provided that the n is similar to the question, and also the probability of success is the same. Let's say you get the pi is 0.15. Okay, so there is no 0.15 here, so you cannot use the table to calculate from the table. So the pi is limited to what is available, 0.05, 0.1, 0.2, 0.3. So if let's say I change this one to 0.25, for example, so 0.25 is of course not here, because after 0.2 you get 0.3, so 0.25 is not available. So either you need to calculate manually using this formula, or you can opt for using this online calculator. Of course, if you were to take this exam face to face, you cannot do this, okay, on a laptop. Okay, so you need to use the manual formula to calculate. So I would suggest that you use your scientific calculator. Okay, figure out how to solve for this. Okay, it's quite simple to do. Okay, so that is how to calculate simple probability question from binomial. Okay, and also the mean and the variance, okay, from the binomial distribution. Okay, so the rest of the slides will be on other examples related to binomial distributions. So we will do this, we will discuss this, and then after we finish these slides, okay, and then we're gonna start on some questions from the book, okay, for us to do. And when we are discussing questions from the book, okay, I will expect everyone to share your screen, okay, whenever I call your name, okay, because that is the only way that I know that if you are doing your work. So whenever I call up your name, make sure there is no delay in switching up your screen, okay. Okay, so that is okay. So then now, okay, another example here. N is equal to 6, pi is 0.05, and x is equal to 0. So basically here the case is 5% of all phone calls are dropped. Okay, 5% means 0.05. Okay, as I mentioned, it can be in terms of proportion or it can be in terms of percentage. So here the value of pi is referred to as percentage, 0.05 or 5%. And what is the probability that out of 6 randomly selected calls, none will drop? So from this statement, there are 2 information. One is the number of trials, and the other one is the probability of x, the x value that you are looking for. Okay, so what is the probability that out of 6 randomly selected calls? So this refers to the number of trials or the sample size. So from 6 events or from 6 trials or 6 calls, what is the probability of 0 will drop? So it's similar to the previous one. You are calculating px equal to 0. So if you refer to this one, of course, 0.05 is here and px is equal to 0, then you can refer to, the number of trials will be 6, right? So we need to refer to 6. Okay, 6, n equal to 6, and pi is equal to 0.05. So px equal to 0, we are looking at 0.735 as the answer. Okay, so that will be the solution here, 0.735. Okay, so if you were to do this on the calculator online, it will be n equal to 6, k equal to 0 as well, and this will be 0.05, and you should get 0.735 as well, okay, as the answer. So simple, no problem. Okay, so there is no excuse that you shouldn't be able to do this, okay, especially when you have the online calculator to help you to get the answers. Okay, so here one additional part here. Okay, what is the probability that exactly 1, 2, 3, 4, 5, or exactly 6? So if you are given different questions, decide x equal to 0. So x equals to 1 is here, x equals to 2 is here, okay, or this one. Okay, x equals to 1, x equals to 2, x equals to 3, x equals to 4. So this is only for the value equals to, okay, x equals to 2, x equals to 3, until x equals to 6, okay, because you have 6 events, so of course the number of trials or the number of x maximum will be 6. If your n is 7, the highest number will be 7. So it corresponds to the highest with the number of your trials for your n. Okay, the highest number that you can calculate depends on, and you can see that the value of probability will become smaller as you increase the number of n. Okay, so because this is logical. Okay, if there are out of 6 trials, the probability to get 6 all calls drop, meaning very, very small, meaning the probability of all calls will be dropped, okay, from all the trials. So the chances for that to happen become smaller and smaller. So that is one of the the thing that you get from this experiment here. Okay, so so that is one thing. Okay, and then the shape of the binomial distribution, and you can see this is just a simulation. Okay, what is the shape of binomial distribution when we increase the value of probability of success, but we keep the number of trials the same. You can see here n equals to 10 throughout, meaning the number of trials remain the same. But as the probability of success, pi, increases from 0.05 up to 0.7, you can see that the shape of the distribution becomes a normal distribution or zero skewness. If you recall from chapter 1, okay, the pattern of your distribution, you have positive skewness, zero skewness, and also negative skewness. Okay, so for a shape like a bell shape, the bell shape distribution, or what I call as normal distribution. So when you increase the probability of success, okay, the shape of the distribution will tend to become zero skewness or normal distribution. Okay, it's the same thing here as well. Okay, when you increase the number of trial, okay, but you keep the pi constant. Okay, here the previous one, you keep the n constant, but you increase the pi. Okay, but in the second slide here, okay, the same output you get, you keep the pi constant, the other way around, but you increase the number of trials. Also, the shape of the distribution will tend to become zero skewness, meaning it approaches a normal distribution whenever you increase the number of trials. Okay, so in both cases, whether you increase the number of trials by keeping pi constant or the other way around, okay, the shape of a binomial distribution will change in terms of from not normal distribution to a normal distribution, or from, you can see here, this is almost like a negative skewed distribution, okay, but the shape of the distribution will shift to or change to a relatively a zero skewness or normal distribution when you increase the number of trials. Okay, so that is one two observations that you get, okay, when we change the number of pi or n, okay, and what happens to the shape of the binomial distribution. Okay, so again, this is another example, and you can see here that when the pi is 76.2% or 0.762, of course, you cannot use this table because the table only provides the value of pi in a nice number, okay, 0.3, 0.4, 0.5. So when you see a question like this, automatically the table will not be useful because there is no table for pi equals to 0.762. Okay, so you need to convert this in terms of proportion. Okay, so your pi is 0.762. Okay, and the number of trials will be 12. So this will be your n. Okay, n equals to 12. Okay, and you want to calculate exactly 7, or the px is equals to 7. So you want to know what is the probability of x equal to 7. So x means the front seat occupants use seat belts. Okay, so that is the event here. So what is the probability of 7 vehicles wearing seat belts? Okay, 7 of 12, meaning you want to calculate px equal to 7 from 12 events. Okay, from 12 number of trials, x will be 7, given that pi is 0.762. Okay, so you only need these three information: the pi value, the n, and also the x value, because from the formula just now, okay, ncx, okay, n, so you need n, the number of trials, x, the probability of x that you are referring to, and also the pi value. Okay, so here, again, using the formula, when px equal to 7, you get the value to be 0.0902. Okay, just plug in into the formula 12cx, okay, meaning ncx, n is your 12, x is 7, meaning you want to calculate px equal to 7, and pi is 0.762. Okay, pi by the power of x, which is 7. The rest is you just plug in into the formula, or again, alternatively, you can also obtain from here. So n will be 12, your k will be 7, your p will be 0.762. Okay, so number of trials 12, the probability of success 0.762. You want to calculate px equal to 7. Okay, so you should be able to get the same answer as the one. Okay, 0.0902. Okay, similar to this one, 0.0902. So you can get the answer directly from this online calculator for the first line here. So the first line refers to obtaining the value when px equals to something. Okay, but the other two is for more than or less than, or at least less or fewer than, or more or equals to. Okay, so these are the other two. So we will see what kind of questions that will require you to apply one of these two lines lah. Okay, so that is how to calculate. Of course, when you watch this presentation from me, okay, you will not be able to know how to do it unless you do it yourself. Okay, either manually or using whatever tools provided. Okay, the online calculator or whatnot. Okay, so this is so far what we have done is calculating exact value of x, meaning px equal to 0, px equal to 7. Okay, previously we calculate px also equal to 0. Okay, so okay, what if you want to calculate an event that requires in terms of the symbol or the notation will be more than, or more and equals to, okay, or less than, or less and equals to sign. Okay, because you know in mathematics you can have beside equal to, you also have these other four signs. Okay, more than, more and equals to, okay, or less than, or less and equal to, meaning this one you include, this one you exclude the value that you refer to. Okay, so there are four other possible scenarios beside calculating the value x equals to sign. Okay, so here, for example, okay, from the same experiment, n equals to 12, pi is 0.762, and now you want to calculate at least 7. Okay, so at least 7 in mathematics, it will be greater or equal to sign. Okay, so I do not need to teach you what it means by at least. Okay, so this is just English word that you need to learn. Okay, if you do not know, then check it from the dictionary. Okay, so px at least 7. Okay, so meaning when you have 12n, so we know that you cannot exceed 12 because the number of trials is fixed at 12. So px at least 7, or more and equals to 7, then it will be 7 until 12, 7, 8, 9, 10, and 12. So you need to calculate this probability if you were to calculate this probability manually, okay, meaning that you need to repeat the process from the formula NCX and whatnot, okay, from this formula here. Okay, so you need to repeat the process 1, 2, 3, 4, 5, 6 times, meaning you need to calculate Px equal to 7, Px equals to 8 until Px equal to 12 using the NCX formula just now, and add everything, and you should be able to get the value of at least greater than 7. Okay, at least 7 or 7 more or equals to 7. Okay, so the value will be 0.9562. Okay, 7 or more. Okay, so there are different ways for the English word that you can use to describe at least 7. Okay, besides at least 7, you can also write more. If you put more than 7, meaning 7 is not included. Okay, meaning 8 and above. Okay, but if you want 7 to be included, okay, beside the word at least, it can also be 7 or more. Okay, what is the probability that the front seat occupants in 7 or more? Okay, the word or means usually you add the value 7 is included. Okay, 7 or more means 7 until 12. Okay, so here is the manual process. Okay, so here from this online calculator here, okay, so you are given another 2 solutions. Okay, here is the probability of exactly or fewer. So what this means is that this line means less or equals to 7. Okay, exactly or fewer mean 7 or less. Okay, and then here exactly or more, meaning this part here is more or greater than 7, or in other words, at least 7. Okay, so this one 7 and more, this one 7 and less. Okay, so here meaning 7 for this part here, it's 7, 6, 5, 3, 2, 1, 0. Okay, but here is 7, 8, 9, 10 until 12 because we have 12 observation, 12 n. So 7 until 12. So this one will be 0 until 7. Okay, for this one. Okay, for this one it will be 0 until 7 because the event can start from 0. Okay, Px equal to 0, Px equals to 1. So here referring to 7 or less or 0 to 7. Here it will be 7 or more, meaning 7 until 12. Why 12? Because we have n equals to 12. Okay, so the one that we are referring to from this slide here, okay, because you want 7 or more, then we are referring to this third line here, 7 or more. So you can use directly this answer, meaning you get 0.9563, which is similar to this one, 0.9562. Okay, it will just maybe differ by 0.0001. Okay, just a slight difference. But if you round up to 3 decimal places, it will be the same answer, 0.956. Okay, so this is also 0.956. Okay, so for the third one, it will be similar to what you are looking here, 7 or more. Okay, so what if from the same example, okay, I change the question at least 8. Okay, mean that it will be Px greater or equals to 8. Okay, so that if x greater or equals to 8, you know that when you key in from the online calculator, okay, so you just need to change this one to 8. Okay, and then when you click calculate, you should be able to refer to this one. So this will be 8 or more. Okay, if you want x at least greater or equals to 8, or at least 8, meaning 8 and above, so this will be the answer. Okay, this one is exactly 8, or x equals to 8. This one is 8 and less. Okay, 8 and below, meaning 8, 7, 6, 5, 3, 2, 1, 0. Okay, so but what if I change not at least? I just use the word okay, more than 7. Okay, so more than 7 is what? So it means Px more than 7. Okay, just now I mentioned that, okay, in mathematics, you can have 4 symbols. Okay, more than, at least, less than, or less and or equal to. Okay, so more than means without the equal to sign lah. So more than 7 means 7 will not be included. So mathematically, if you were to write this, if you were to change this sign, more than 7 will mean x greater or equals to 8 lah. Okay, correct. Because when you want to calculate more than 7, meaning it will be 8 and above, meaning 7 will not be included. So if you were to write this in an equal to sign, it will be px greater or more than 8. Okay, so if you want to key in from the online calculator, so you know that when you key in 8, okay, when you put 8 number, you put equals to 8, you don't only get equals to 8, you also get the value 8 or more. Okay, so if you are given a question like just now, more than 7, okay, so more than 7 means 8 and above. So if you key in 7 here, then you will not be able to solve the problem, because when you key in 7, the calculator only gives you equals to 7, less or equal to 7, or 7 and more, okay, but not 8 or more. So so you need to be clever in how to apply the online calculator based on what is provided to you here. So you are given less or equals to, and also more or equals to. Okay, so if you want to calculate something like more than 7, so you need to use 8 here, okay, not use 7. Okay, because more than 7 means 8 and above. Okay, so having said that, so whichever direction, okay, so for example, if we change this one to, let's say, less than 7, okay, so okay, what is the probability the front seat occupant in less than 7 of the 12 vehicles? So when less than 7, it will be what? It will be from 6, 5, 4, 3, 2, 1, and 0, right? Meaning less than 7 means 7 will not be included. So you will start from 6 and below, 6, 5 until 0. So if you were to write this mathematically, what will the notation be? It will be px less or equals to 6, right? Because in your online calculator, it only takes the equal to sign, whether more or equals to, or less and equals to. So less than 7 is also equal to x less or equal to 6. Okay, if you do not understand this, then you need to learn back your secondary mathematics. Okay, because you don't learn this at degree level, this equal sign here. Okay, so less than 7 means 7 is not included. So it means 6 and below. So mathematically, you put the sign less or equal to 6. So if you were to use the online tool, so it will be, you need to put 6 here. Okay, so when you put 6, although you want to find less than 7, okay, because 6, this is not relevant to you. What you want is this one. Okay, because this second line refers to 6 or less. Okay, less or equal to 6. Okay, exactly or fewer. So it will be P0.0436. Okay, because exactly or fewer means 6 and below. Okay, exactly or more means 6, at least greater than, or at least 6. Okay, 6 and above. Okay, so even though the questions states less than 7, okay, but you need to view this as when you want to convert in terms of the equality sign, so it will be 6 and below, or less or equal to 6. Then you will be able to key in the calculator here. Okay, because if you put 7, then you will not be able to get the answer here. Okay, but if you put 6, then you can refer to the second line, okay, which will be similar to less than 7. Okay, so the next will be on Poisson, which what we will cover next Monday. Okay, so for the